Okay, here's an additional video hint on some of the homework from SMAC. All right, so in the second problem, you're given a system, and it's a first order plant that you have. All right, so here's the plant, G. And then you put in a controller, and the problem statement says it's a PI controller. So the P means it's proportional to the error, and I means it's the proportional to the interval of the error. Okay, so when I talk about the error, you notice that you have R is a reference signal, and then here's the feedback of the output Y. So here's the output coming this way, and you subtract the difference to form this error signal. Okay. All right, so that gives you an idea of the terminology. All right, so the P part is proportional, the A part is interval. All right, so from there, it's just a matter of finding the closed loop transfer function, so Y over R. And we've talked about that this is something you should just memorize the formula for, at least for this class. You can always go back and look at these things if you have to tackle a control problem from scratch and you don't remember all the theory. Okay, so we start with this, all right, and then algebraically we just plug in these S-domain expressions for GC, the controller, and the plant. All right, so what we end up with is a second order transfer function. Okay, and I think in Professor Miller's notation, he's calling this T for the closed loop transfer function, T of S. All right, so hopefully you understand the big picture here. What we're doing is we're looking at how to shape the output response. Okay, so we'll talk about that for a second. All right, you have a couple of knobs that you can turn here. Let me move some of this. Oh, it's not going to let me do that. Oh, this is frustrating to me. I can't get it to work.